So we're now done with our design of purlins, so we will now proceed with the design of our truss. So I already got modeled here our truss for the sample project right here. So this is a span length of from support to support 17 meters. The total length of the truss is around 21 meters. So this is already modeled, pre-modeled ko na yan. So what we're going to do next is to assign a preliminary material sections. So let us consider the lightest section available for, let's say, let us use a angular section. Okay, the lightest section here is a 2x2 by 1/8 inch angular bar. But for this kind of truss, since this is a long span truss, so we will use ST, stands for short leg back to back double angle. So we will going to use a double angle truss. Okay, we will apply that to all. Just assign that to view and then click assign. So we're going to see that in a 3D rendered view. It would look something like this. So now if you notice this bottom chord right here and the top chord, if you compare the two, the top chord against the bottom chord, you will notice that their position is inversed, meaning this one is upside down, the bottom chord is upside down, and the top chord is upside down, while the bottom chord is right side up. Okay, so what I did with that earlier is I assigned a beta angle right here. So all this bottom chord right here highlighted in red, I assigned this angle in degrees 180, because the initial position or the default position would look something like this top chord right here. But if you will assign the beta of 180, it would turn upside down like that. Okay, so when we now have our property, we will proceed with our specification. So the top chords and the bottom chords, in actual, it is not cut in every node, right? So it is a whole length. So the only members cut are these diagonal members. So what we're going to do with these diagonal members is we're gonna assign this as truss members. So how to do that? Just click this beam and then truss members, click add. So we're gonna assign member truss for these diagonal members, all of these diagonal members right here. So just going to highlight that. I will use this drag line selection mode. Just drag a line like this, and then for multiple selection, just press Ctrl in your keyboard, assign to selected beam, assign, yes, okay. So all of these diagonal members are now assigned as member truss. Okay, so next we're going to assign supports. Support condition for this is pin. Let us consider this as pin. Supporting here, these nodes. So let's assign a pin connection right there, just like in our analytical view. Just resting at the top of the columns. So we will assign that as pin connection. So now we're done with that. We'll go to load and definition. So we're going to assign loads now. So we have dead load, we have live load, and of course we have wind loads. Now the same is true with the purlins. We have the wind load downward direction, which has a positive sign, and we also have a wind load which has a negative sign. This is the load for upward direction, so we're going to add that. So we also have load combinations. We'll assign load combinations right away. So you can still remember we have that 1.2 dead load and 0.5 live load and 1.0 wind load. Let's copy this. Click add, paste that there, and load negative direction. So 1.2 for dead load, 0.5 for live load, and 1.0 for the wind load, the negative direction. So click add. Another combination we got is 0.9 dead load plus 1.0 wind load. So dead load and wind load. This one is 0.9 and that one is 1. Let's copy this. We're just gonna paste that with the next loading combination right here. Just change that negative positive sign into negative sign. So just like that. 0.9, click add. So we'll also add this loading combination for the deflection check. So right now we're going to assign the values for the dead loads. Just click this. So just first we will assign for the self load, factor of -1. Click add, and then member load. First member load we're gonna assign is the roofing, corrugated roofing sheets, right? Corrugated roofing sheets with a value of 0.1. So just multiply that with the spacing of trusses, 0.1 with the spacing of trusses of 3 meters, so we will add 0.3. Okay, 0.3. We will also add the purlins. So how about the purlins? So if you remember this purlins right here, we add a still takeoff command, right? So we will recall that still takeoff the result. It has a result of 2.983 kilonewtons with a total length of 34 meters. So what can we make out of that? 2.983 divided by the total length of 34 meters and divided by the spacing of the purlins, which is 0.886. So we can come up with a value of 0.99 and then multiply this with the spacing of the truss, which is 3 meters. So we have 0.297. 0.297. So let's add 0.297 kilonewton per meter. And what else? We also have the loading for ceiling and the MEP, which stands for mechanical, electrical, and plumbing fixtures. So we can add this to 0.1 plus 0.1 is 0.2. 0.2, just multiply that with the spacing of the truss, 3 meters. 0.6. So let's add 0.6 here. Okay, and we'll assign this. For the self weight, just assign that to view. For the corrugated roofing sheets, 0.3. Let's assign that to the top cord. So corrugated roofing sheets is acting on the top cord. Assign to selected beams, assign 0.97 for the purlins. Again, let's assign that to top cord. And ceiling and MEP is acting on the bottom cords. So select this bottom cord right here. Try to select the beams, assign, click yes. Now for the live load, the value for the live load is 0.6. So 0.6 multiplied to the spacing of the trusses, 3 meters, we got 1.8. Input 1.8, click add, and that's the live load. Apply that to the top cord of the trusses. Okay. So how about for the wind loads? So if you remember, we already solved that wind loads for the purlins. The same is true with how we come up with the value for the purlins. So take the effective area of the truss and then locate that in this table right here. So we just input these values right here for the positive pressure, 2.55. Okay. Again, number load, negative 2.55, and then that is local y-axis. Okay, add that as a local y-axis. And select the beams, assign. Yes, so if you notice, the direction of the loading is acting normal to the surface of the roof because we assign it as a local y-axis. So how about for the wind load in the negative direction? So if you will see this, we have two values. Actually it's three, but we'll not include the zone 3, only the zone 1 and the zone 2. So the zone 1, we will apply that for the edges, at the edges of the truss. So if you remember, we already calculated the width at A, which is 1.7 meters. So you just measure 1.7 meters here in your model right here. So let's say from the edge going to this node right here, so it says 1.39. so it is short of we need 1.7, right? So how about if you measure this to this next node right here, it's 2.085. so perhaps we will just apply this zone 2 pressure 7.32 zone. This is zone 2 pressure in this area right here, as well as in this other side. So first we'll add that. So member load, negative 5.16. We'll apply that as simply 5.16. and then direction is local y, and then the other one is 7.32. 7.32. Once again, it is in a local y direction. Click add. So the 7.32, let us assign that in these edges right here, as well as here. So assign to selected beams, assign, yes, and this 5.16 for the rest of the top course. Assign to selected beams, assign, click yes. So that's it. That's all for our loadings. We have your dead loads, live loads, and wind loads. Two types of wind loads: wind load downward direction and wind load upward direction. So let us now proceed with our analysis. Just perform analysis. Click add. And then let us include the load list we're going to consider. It's only these loading combinations, right? So click add. And then, already done with that, let's proceed to the design. So this is steel design. We're using AISC 360 for the code. And then for the method, we're going to use LRFD, and the yield strength of the still we're going to use A36. Click add. Okay, so just assign this to view, assign, and you will also assign check code, assign, as well as steel takeoff. Click assign. So that's it. Let us test this. Analysis. Let us check for failing numbers. So there are no failing numbers. If you try to check for the post-processing here, the biggest unity ratio is 0.882 near the support. That is how to model and design truss.